I. Here, so we are discussing in this the past paper questions from 1990 up to certain extent, most probably it may be up to 2010 like that. The first one, 1990 question. Right. There what it says. First question. But I want to find the questions first. Question number 8, no? Right. Using dimensional analysis, derive an expression for the viscous force acting on a sphere of radius A in fluid of coefficient of viscosity eta with the velocity v. Derive expression for the viscous force acting on a sphere. So I'm not going to do that. Always you have to check the previous video, that is viscosity part 4. There you get the explanation of all those theory. But here, F is here, downwards mg, upwards u. Using this method, you can prove it. It is there in the part 4. Then the next one. There is a cavity in an aluminium ball of external radius 1 centimeter, mass 2.5. I will draw. There is a cavity in an aluminium ball of external radius of 1 centimeter, mass 2.5. Directly the mass is given. So therefore, this is 2.5 into 10 to the power minus 3 into 10 newtons. You marked as it is given. The other one is when it is released from the bottom of a deep tank containing glycerine, it travels upwards. The density of glycerine and its coefficient viscosity are given. After that, they are asking the acceleration. This is actually 1988 question. So then what you have to do is you have to prove that equation 2a squared rho minus sigma over normally 9 eta is equal to, this is equal to terminal velocity. But they are not asking that. They are asking acceleration, its velocity is 0.1. So what you have to do is, this is, some students might use this. F equals 6π a eta v. So question. Then after that, v is given, eta, all are given, so you can find f. After that, m is known, then you can apply f equals ma. From there, you can find a. When they are substituting this, always I said in the past papers, a is in meters, you have to write in the converter and write. Eta should be written with ns m minus 2 or in m s minus 1 p minus 1. So then pi, just write 22/7. If it is given as 3.14, then use that one. Sometimes they might give it is approximate value. It's approximate value, that is approximate value is 3. Normally they give like that. So note down only this. After that, substitute and get the answer. It's a very simple question. Now they have given you another one. Draw a label diagram for the apparatus that you would, that is a different one. Next one. Question, that is 1990 question. What is understood by the terminal velocity of an object falling vertically through a homogeneous viscous liquid? The answer must be when it is falling down. Like eighth one. Such answers you should know properly when you are giving the answers. They are asking the explanation actually. Then write. When a sphere is falling in a viscous liquid, due to its weight, actually it goes into the liquid. In the liquid, there are 3 forces acting. Number 1, its weight vertically down. Number 2, upthrust vertically upwards. Third one, viscous force vertically upwards. Then there is a resultant force, mg minus u minus f, vertically downwards. Due to this resultant force, sphere has an acceleration vertically down. Then its velocity increases gradually. When you say it increases, when the velocity increases, according to the equation, Stokes equation, F equals 6π a eta v, viscous force increases. Then there is a special situation, or we can say particular situation, where u plus f is equal to mg. In other words, no resultant force now vertically downwards. Then from that situation, there is no acceleration. actually the maximum velocity the sphere attains in the instance where acceleration becomes zero is terminal velocity. After that, sphere falls with this constant velocity, which is terminal velocity. This is the good explanation. Then we'll go to the part 1. Here it says, derivation is not necessary. Metal sphere of mass 0.1 has radius given and in meters it is given. The sphere is connected to spherical shells, same size, that means radii are the same, but each having the mass of 0.4 kilo, 0.004 kilogram means of light inextensible threads as shown in the figure. That day when I was explaining in the other one, that time I explained even those are to be connected with inextensible light strain. In this question it is given as it is. Then after that you have to mark all. So when you are marking, mark the whole situation in a proper way. Now it is in the first shell, second one and sphere. Then you have to mark the forces there. The first one is given as, first you mark the weight, mass or weight. Right? The first one is 0.01, that is downwards, 0.01 into 10 newtons. There you mark the, then you have to mark the tensions, T1, here T2. After that, other weights also you can mark because they have given it as 0 point other than this 0.004 into 10 newtons. Here also the same 0.004 into 10 newtons. Now we mark tension, and when you are marking, better to mark everything on each sphere or shell. Then it is easy. Then mark upthrust. Radii are the same. No? Then displaced volumes are the same. Then you write radii are the same. Therefore, upthrust or displaced liquid weights are the same. Therefore, upthrust on each shell and sphere are the same. We'll say U. Then you mark U here from the center, then upwards U, from the center upwards U. Then we have to mark viscous force. Then you consider viscous. F is equal to 65A eta V. After that, you note down when the system comes to terminal velocity, all shells and sphere are having the same terminal velocity V vertically down. You are not down there. Here, then write radii of all shells and sphere are the same. Therefore, viscous force is also the same on each. That is F. You get marks for the diagram normally. Here, just try to understand how I mark. First, I mark all the weights. Then I mark tensions. Then I mark upthrust. I explain in my answer what you have to write. Then here also F is the same. Right. After that, you have to apply after that what you have to do is find U. How to find U? First you write volume of each, that is use 4 pi A cube. From that you can find the volume. After that you write weight of the liquid displaced. Then after that you say therefore upthrust is this much. Those steps note down. After that, you can apply F equals MA. But since it is first time like that, I will write for that day in other one. Here it is the video there, part 4. You get all those. Then F equals MA for each. For this once, for this, and for this separately. Then why I am writing actually it's easy to understand. Then for the sphere, you write properly sphere. Then they are vertically down 0.01 0.01 into 10. As it is, I'll write 0.01 into 10. Then minus U minus F minus T1 is equal to M into, this is F equals MA, 0. So that is 0, first equation. Then you get the equation. For the middle one, middle shell, then write middle shell. Again, downwards, we are applying. There the weight is 0.004 into 10. Into 10. Here T1 is downwards on this. Then plus T1 minus U minus F minus T2 is equal to M into 0. Second equation. Then you have to consider the other one. The other one is top shell. There again vertically down, 0.004 into 10 plus T2 downwards minus U minus F is equal to M into 0. That means 0, third equation. Look at this. When you add 1 plus 2 plus 3, see what happens. When you add 1 plus 2 plus T1 minus T1 plus T1 cancel off. Got it? Then minus T2 cancel off. After that you get 0.01 into 10 minus 3U minus 3F, got it? Plus 0.04 into 10 plus 0.04 into 10 is equal to 0. So F is equal to 658 V. Understood? The V is unknown, others are known there, U is known, then you can find terminal velocity. Note down quickly. Anybody who doesn't have these papers from 1988 or 1990 up to 2010, others are normally available. Send me a WhatsApp on 00777792289. There you write your name, school, name and school, and send me a WhatsApp. Then I will directly speak to you and send you the papers, or I will send without calling you. That number, I'll write it again. Not 777792289. Okay. Now we'll go to the other part of this. Then it says, here pi is not pi is given as 3, not in is not there. In all your calculation, that is. Second one, if the thread is cut at the point X after the system has reached the terminal velocity, determine the magnitude and direction of the new terminal velocity of the system. Now we'll see what has happened, what is happening when at X. If you cut it at X, what would happen? They are asking, remember, of the system, that is very important. Cut the white X after the system has reached its terminal velocity, determine the magnitude. System is concerned, at least more than one items or objects must be there. The X is actually here marked. You cut it, then this goes vertically down separately. The other one is concerned, no tension here. Weight, upthrust, same. F, same. Now T2 will change to T3 and other things are the same. New terminal velocity is there. Therefore, you explain. Now the system is different. Therefore, new terminal velocity is V dash. And you consider this and redraw that. Apply for this one, apply for this one. Then, just like the early method, it is easy because only two equations are there. But your equations, T is T, the bottom one, middle one, we had T3, early T2 and T1, now we don't have. So if you want, I'll write it vertically. Then now it's still the weight is concerned. The weight value is there. First you consider the weight of the system. Because you have to check what is the direction it's moving. So that is equal to 0.04, 0.04 plus 0.04, that is 0.08 newtons vertically down. Then you consider upthrust. Upthrust, total. Total means on both. Total upthrust. Because we calculated upthrust early, then same upthrust twice you are getting. Then upthrust is concerned, I think it is 2 into 4 into 10 to the power minus 2. Right? That is the, no, minus 6. So here you get a different value. That value is concern you check in. When you check all those, calculate and see, normally you are getting here, upthrust is upwards larger value than 0.08. Then the object is moving upwards. Then the object system is moving vertically upwards. Then there is a problem. Then F changes. F is downwards now. F dash. Here also, because against the motion. Now you write the second equations for the second part. The equation is then for the upper one, vertically upwards, U minus T3 minus F dash minus 0.04 into 10 is equal to M into 0. Still, this is upwards now, not downwards. You have to check it always. 0, you can get, for the second one, this is written for this, the other one, upwards, T3 plus U minus F dash minus 0.04 into 10 is equal to m into 0. F equals ma 0. Now when you add these two, you can consider fourth equation, fifth equation and add them together. Then T3 cancels off. After that, you get 2u minus 2f dash plus 0.04. Another 0 is there. 0.04 into 10 plus 0.004 into 10 is equal to 0. From that, f dash is equal to 65a eta v dash, new terminal velocity. U is known. So we calculated u initial to find the direction. So therefore, that value, 2u value directly substituted there. There is no need to directly, you are getting the certain answer for the upthrust, no, to both upthrust on the system. From there, we consider that it's moving upwards. From this, you can find the answer. Then we'll consider 1992 question. In this, the first part, all those are concerned actually mechanics. Now very rarely they combine and give you. Some students do not like to do these questions. But anyhow, this question I will skip and go to the other one and I'll do it as the last one. Right. Next one. The previous one, which I said, no, we'll do 1992. After that, I said 1995 question. The 1995 question depends on some muddy water or mud is dissolved like that. Those questions normally using the dimension analysis show that the viscous force of acting on a sphere of radius a is moving with the velocity of in a liquid velocity that is v, and the coefficient of friction is eta, and that equation is given as F equals K eta A V. Because K is normally 6.5, it is not given. They are saying it's a constant that can be normally Stokes equation or law can be written as it is. A sample of muddy water from a river is collected to a tall glass vessel and allowed to sediment at time t equals 0. It can be assumed that the mud particles attain their terminal velocity within a negligible short time. That means negligible short time means from the beginning it attains the terminal velocity. Assume that the muddy water contains equal number of spherical particles of all sizes and initially they are distributed uniformly in the volume. Derive an expression for the terminal velocity V of mud particles of radius A and density. I'm not going to do that because the previous one I have explained it, how to obtain that. Part 3, viscosity, there you get the equation. I will just draw the needed forces, mg downwards, then u upwards, then it's moving down, then F. Those are the forces. Then you write and get this equation. V equals terminal velocity is V is equal to, here F is 658 V. Go through that and prove the same thing. Finally, you get 2A squared rho minus sigma G over 9 eta. This is the equation you have to obtain. As I said in that, this is not standard always. You have to prove and get it. But here remember K remains still. But early when we found K is not there, different now you get the different equation because K is not given. So therefore you simplify and see that is a different way you are getting. After that, then first part it says F is equal to K A eta V and prove the dimensionally it is correct. So left hand side, right hand side, I did this. There you can see and you prove that K does not have any dimension. That was done early. But here you have to get us K is equal to 6.5, note it down. K is equal to 6.5. That is to be considered here. Then that means same equation which I wrote earlier on the board must be obtained. After that everything is given. Then calculate the time taken to sediment all the particles with 8 into 10 to the power minus. Right. First they are asking derive an expression for this. Second one they are if the densities all are there, calculate the time taken to sediment because they are talking about now the one with the radius. That radius is considered as 8 in 10 to the power 8 into 10 to the power minus 6 meters. From that you get a certain, but remember no collisions there, we don't care. Now first you find the terminal velocity. After that, the height of the jar is needed. Jar or the water. Water is set and it is 1 meter. Then it starts its journey from with the terminal velocity from the initial state. So then from the free surface. So therefore, part 4 video you can, I have explained all those. There T, time is equal or velocity is equal to displacement divided by time. T is equal to S over V. S is H, which is equal to 1 meter here, divided by terminal velocity, we found it. From there, we can get a time. So then the one, they are asking in a different way. You have to understand that, right? Calculate the time taken to sediment all the particles. Now, this is a mixture. No? We'll say this is the particle with 8 into this particular radii. In one few particles may be at the top, near the free surface. Others are at different places, maybe one just before the bottom also. So, all are coming down and getting settled at the bottom. Those are called sediment, the mud. But last one which is coming is which is at the free surface. Then we are calculating the time for the freeze one or the particles at the free surface. Then from this we can find the time. So this is these particles are at the top within particular time or time taken to reach here can be calculated. So by the time this comes here, all the other particles with the same radii are at the bottom or as sediments. Right. So then the next one. Then they have given another radius. They are asking if the radius is different, the second one, what is the time taken to reach? Then you can find as the same way, only the radius is different. Then fourth one, once the sedimentation of particles having 8 is over, what fraction of particles with A is 3 can be found inside the sediment layer? Because others are also falling, no? Then you can consider the time taken for the second one, second radii ones. So that means 3 into 10 to the power 3 into 10 to the power minus 6 one. Normally the time taken there is calculated, you get second one. T2 is 266. In seconds I am giving the answer. 67 seconds for the second one. For the first one, you had to get the time. We found it early. That was 3,750. From the answers I gotten. Now they are asking by the time. Then here look, first one time is greater. Then number of particles there you can find. According to time, no, it happens. So then second fraction we have to consider. This is smaller, this is larger. Then the time is concerned, first one is concerned 3,750. So that is to be considered first. And then consider T2. How to find it? You consider T1. Then by that time, you can calculate the distance it traveled. So we assume everywhere the mud particles are there. Mud particles are there. Now, second radii is concerned, according to that, that means 18 to 10 to the power minus 6 ones. And the other one 18 to 10 to the power minus 4. So both are concerned, what happens? When this reaches the bottom, everything in the larger ones are deposited. Within this time, the particle which was at the top, the second radii, must be here. Then we can calculate this height is known. Then we can calculate this height and the amount or the time taken is known for this. Then after that, get the ratio. Then you are getting the answer. Try to do it. I'll explain if you want again. Remember, this particular time is concerned, all are at the bottom. Because we calculated for the one which was at the surface, reached there. Then, but other small ones are concerned, it takes more time. Within this time, the particles are concerned, you can find the height it can, because different terminal velocity. So therefore, within this time, the one which is at 1, I will consider. Then h dash. Now what you do is, new terminal velocity, h dash divided by time. Time is taken as 3,750. And v dash is known. Then h dash you can calculate. Then h dash is calculated, that means from here up to this, all are at the bottom now, the second one. But the ones with this height is not there. The number of equally distributed, we can consider the volumes. So normally, this is the amount of volume you have to consider. That means 1 minus h dash into cross-sectional area of the beaker or the jar, a dash. That is the volume. Here, this much of particles are there to reach here. But other particles are concerned, that means total number is at the bottom. That means for the 8 ones. 8 ones, it is 1 into a dash. Then divide this volume. We assume that equally distributed. So then here you get the certain number total is concerned, this much of volume, you get a different values. If you want to understand further, equally distributed, all are having the same number of particles at the initial stage. So then large one is having capital N, other one is also having capital N. So then here this volume, total volume you get that much. So in this volume you get it multiplied by n cancel off. So then you get the same. Again I'll tell you, what we do is we consider the time taken the larger one to reach here. After that, within this particular time, the ones from here, the particles have come to the bottom and settled. These ones are concerned still there. So this volume, particles must be considered. So this number is still in the liquid. It is not there actually. Those are still suspended in the water. But volume wise you can consider. Right. Next one. Now we'll go to the next question. Now we are considering 1998. There you get different picture. I have explained this early. Here you get a certain block kept like that. I'm not going to do everything because this was explained early, but I will show you how to get it only. This is the one. Here it is in the liquid. This is the horizontal table. First it says sphere of radius 2 into 10 to the power meters attain terminal velocity 3 mm when it is allowed to fall, rest in a viscous liquid. Draw a sketch to show the variation of velocity of the sphere time. So then here you can calculate the values. 2 into 10 to the power minus 2 they said. So therefore, terminal velocity is 3 and the calculation is not needed because we know the sketch, no? Sketching is concerned. We can say the terminal velocity wise, the first one is this and mark terminal velocity 3 ms minus 1. After that, there's talking about another situation. That situation, you calculate the terminal velocity and they are asking you to plot the graph on the scene. So therefore, second situation, you get 1.5, roughly 1.5 is half of this. So second one is concerned from 0. It should reach the same place, terminal velocity like this. But is first one, second situation 1.5 they have given. So terminal velocity from the beginning you can consider this because they have given both. So first one is like that, second one is like that. After that, the question says, when the sphere is connected to a block passing just like that, kinetic friction between the block and the horizontal surface on which is placed is 0.4. The pulley is light and frictionless. What is the tension in the string when the sphere attains the terminal velocity? So that is, they are asking normally, this question is concerned, it is normal mechanics. Inextensible, we can say this is T1, this is T1 because pulley is smooth and strings are light and inextensible. There is a frictional force here against the motion, that is F dash, that is to be marked. And they have given you kinetic friction 0.4. Kinetic friction is 0.4. And mass of the, you have to consider the mass. Mass is 0.1. So therefore, 0.1 into 10 newtons. R should be there. Mechanics this part. So then this is 0.1 into. We know F equals mu R. Here it is moving, then since it is moving, this must be kinetic coefficient friction. Normally in mechanics, you know, kinetic coefficient friction is slightly less than the static coefficient of friction. It reduces, there is a certain graph also. That's under mechanics. So vertically upwards for the block, then R minus 0.1 into 10 is equal to m into c, no acceleration, or you can say vertically it is in equilibrium, but you can't say it's in equilibrium. The reason is moving. There are two equilibriums we consider in mechanics. One is static equilibrium. The object is at rest, not moving anywhere. But Newton's laws are concerned when a certain object is moving the constant velocity, acceleration 0, that time we say that is in dynamic equilibrium. Dynamic equilibrium means it's moving. But here is also dynamic like that. So, but vertically upwards, therefore we can apply F equals ma. So then F equals ma vertically upwards, when you apply, then you get R minus 1 is equal to 0, R is equal to 1 Newton. Then after that, F equals mu R. Then mu is given as 0.4 into 1. Then you get 0.4 newtons. Just note it down. Then you consider this part. This is in equilibrium. So horizontally towards this direction, F equals ma. It's moving in, A is equal to 0, constant velocity. So therefore, force is T1 minus F dash is equal to mass into 0. So T1 is equal to F dash. So F dash is found. So then T1 is therefore T1 is equal to F dash 0.4 newtons. That is the first part. Second part of the question. First part is sketching story. Next one. Second, when the sphere is connected to a block of mass 0.1 by a stream passing over pulley shown in the figure allowed to fall. So that is also there. Then after that, what is the tension in the string? We found it. Calculate the coefficient of viscosity of the liquid string when the sphere attains the terminal velocity. Now it attains terminal velocity. So what are the forces acting on that? You have to consider that. Now it is B part. Calculate the coefficient of viscosity of the liquid. Can you understand that? Liquid, they are asking because they terminal calculate the coefficient of viscosity of the liquid. Now it is terminal velocity, no? So we found the tension here. For this you apply mg downwards, that is given, u is there, and f is upwards. So you have to mark all those. Then after that, terminal velocity, acceleration is 0. F equals ma, vertically down. Then apply and get the answer there. Downwards, when you apply, how to get this? Mg minus u minus f minus t1 is equal to m into 0. Why? Terminal velocity, acceleration is 0. So t1 we found f658 eta v. From there you can find 658 eta v. V is to be found. U can be calculated according to the radius, and just like the question, mg is known. So therefore we can find v. No, second one, terminal velocity was given. Then we want to find eta. V is 1.5 given, no? So this is eta. Then you can find eta from there. They are asking eta. Right, next one. Now, second situation, they are saying in between this same liquid, layer is placed, thickness of 1 millimeter. Liquid, same liquid, red color. So therefore, this F will consider as F1. Now, this part is concerned, the first one, video 1. So then part 1, I explained this type of questions, that is Newtonian equation. Or the equation, Newtonian equation is F is equal to eta A delta V over delta X. Now delta X is given as 1 millimeter. So that means 1 into 10 to the power minus 3 meters. Delta V. So then if the new terminal velocity is V, we'll say dash, we did not use. So here also it's moving with V dash. So that means constant velocity. Again, we can apply if the F dash is equal to F is equal to ma. But F1 we have to calculate. So then here delta x, this is not moving, this surface. Its velocity is 0. Upper one is v dash. But there you write, when the block is moving with the constant velocity v dash, the upper layer which is in contact with the block also moving with the same velocity v dash. So therefore, velocity difference is, you have to state it, v dash minus 0. That is v dash. Then this is known A. They have given you the block. So then after that, you have to consider eta is the what you found early, that is 0.7 you are getting. Right, then you have to get the area. Surface area of the block is given 2.5 in 10 to the power minus 4. So A is given 2.5 into 10 to the power minus 4 square meters. So therefore that is also known. Eta is known, that is 0.7. Then you can find new value F dash. Oh no, F1. After that, new tension again you can find. How? Horizontally, F equals MA. Like same way. Then T1 minus T F dash. It's better to change the second diagram T2 because early T1. No? Then F1 or T2 minus F1 is equal to mass into 0. So T2 is F1. After that, same way, previous question method can be utilized and get the answer. Write all the steps when you are doing. Students, it's better to such situations are concerned, viscosity or properties of matter questions are concerned. Early papers, normally students think that early papers are not needed to be done section wise. But if you do it like, do those questions from 1990 like that at least, then all the type of questions can be discussed or can be done by you. So therefore, you know everything in the viscosity, even for the surface tension or the elasticity, it should be done like that. If you restrict, sometimes you have a certain idea that very old questions are not needed. When you do these questions, you can understand they have given always different type of questions. And new questions are concerned hard, longer. So therefore, these questions you have to time and do. When you are doing these type of questions, don't use 30 minutes. Use only up to 22, 23 minutes because now new questions are very long. Right. We'll come to the next one. Write down the Poisson equation for the streamline flow of a viscous fluid through a tube, identifying all the symbols. Now you should understand, normally it is steady flow. Steady flow means the one particular section is concerned, cylindrical way it's moving, all streamlines should be having same velocity. Then it is called steady flow. So a streamline flow is concerned, that is steady. Then write down Poisson's equation, streamline flow. So then that is, you have to write V equals pi a to the power 4 delta PO P1 minus P2 divided by 8 eta L. So after that, describe A, describe P1, P2, then eta and L. Like that you have to give. And V. You have to describe V also. Right? That is, actually, V means that is Q. Q is rate. Better write like that and V is concerned, that day I said V is equal to Q is equal to V over T. Then if you are writing V, you have to say for unit time. Better write Q directly. Q is equal to pi a to the power 4 P1 minus P2 divided by 8 eta L. Then describe this. This is rate of flow of liquid in volume. A normally internal radius of the tube. I gave all those in one particular video. The next one. Draw a label diagram of an experiment setup used for the school laboratory to find the coefficient of viscosity water used in the above. So the practicals are in a different way. Another one is there. There you can watch it or see it. Right. Next one, part 1. Figure shows the rough sketch of a syringe that can be used to inject liquid drugs into blood veins. The liquid inside the tube is slowly pushed out through the needle AB by applying a constant force on D. Length of the needle is 2 cm. It has bow of radius R. Assume that the velocity of the liquid inside wider tube is negligible. Draw the variation of the pressure inside the liquid alone. So that is explained by me earlier. So this was a syringe is concerned. You get a syringe like this. There is a part which we have to push inside. Here needle is there. Needle is there. A, B, C. A to B, it's considered as constant volume, that is not moving. Liquid is not slowly moving. So therefore, we assume it is at rest like that in here. We assume, then you write it. Then Pascal law is there. Therefore, everywhere the pressure is the same. So the pressure for the up to this point constant. Pressure A to B is constant. That is explained early properly. And from here to here, P1 or PB, PC. PC is atmospheric pressure. So therefore, it is open. So therefore, PC, then it is drawn. Check with that early one. So there I have drawn. That is the one. And in this one, next situation. First part. If the coefficient of viscosity of the liquid is eta, write out an expression for the force F that has to be applied on the surface of an area A of the top. No, no. Sir, I read in the different place. So then after that they say draw label diagram on an experiment setup that was done. Show the rough sketch. Inject drugs into blood veins. The liquid inside the tube slowly pushed out through the needle AB by applying A. Uh, that means constant force on D. Length of the needle is 2 centimeters. Radius is given. Assume that the velocity of the liquid inside the wider tube is negligibly small. Under this situation, draw the variation that I explained it. When the end of the needle is exposed to the atmosphere, the time taken to push 1 cubic centimeter of the liquid through the needle is 10 seconds. Right? So then this equation, actually I wanted to use that VOT, but after that I change and explain. So now you can find Q. No? Q is equal to V, 1 cubic centimeter. So then 1 into 10 to the power 6 cubic meters divided by time. Time is given as 10 seconds. So you can find Q in cubic meters per second. So SI units, you find it. After that, they are asking calculate the pressure difference across AB. First one, A to B. AB means the needle. Then you use Poisson's equation. Q is this one, you can use. Now Q is known, we calculated separately. Pi is known, A. Then, so this one, radius, internal radius, and they are asking you to find the length is given 2 centimeters, radius is given, assume that, okay, everything is given. Pressure difference A to B. They are actually in the question, A, B is here. Then you can use Poisson. So this is unknown, all the others, this is known, everything is known, then you can find. Substitute properly, when you are substituting, always write on the right hand side, A is how much? In SI units you write. When you are substituting, don't use the units there. Without the units, you can do it. Then we'll come to the next one. Assuming that average excess blood pressure over the atmospheric pressure is 100 millimeters of mercury, calculate the additional force to be force. There are force. Then early force you can find. How? This pressure is known. Now pressure difference is known. Here, this one atmospheric pressure, then you can find PB. So PB minus PA, then you can get the pressure difference they are asking, then directly you find this one, no, you can write it as delta P, then you have to change the descriptions. And after that you can say delta P is equal to PA minus PB. PB is atmospheric pressure, this is found. So therefore you can find PA. So here it is constant pressure everywhere because according to Pascal. So therefore here the PA value. Now PA is equal to that pressure PA is equal to everywhere the same pressure. Force F1 over cross-sectional area A. This is known, this is known. You can find F1 for the previous situation. Now second situation, this pressure is different. That is PATA, that pressure is PB, new one, PATM plus 100 millimeters of mercury. So this can be written in 76 centimeters plus mercury in millimeters 100 millimeters. But if you consider in centimeters divided by 10 centimeters, then you can take the everything together, 76 plus 10, then 86. After that, use H rho G, and use and get the PB, new value. Then you said again the same value here, up to this. Again, you apply for second situation. Then second situation, F2 divided by A is equal to the pressure what we are getting here further. So second situation is concerned, PB we can find, PA unknown. Then again in the previous method, we find the difference. After that, use this one and find a new pressure at A. That is the same here. Then you substitute that pressure here, right? We'll say dash and get second one. Then the difference is the additional force is to be given. That means F2 minus F1. So they are asking additional force. That means first force, second force, the difference. That is additional. Then next question is 2001. 2001 question. A laminar flow of viscous liquid is maintained on a stationary horizontal plane. The top of the liquid is moving with the constant velocity v and the stationary bottom layer is at depth of d. If the coefficient of viscosity of the liquid is, write down an expression for the force F has to be applied on the surface of the an area A of the top layer. So here again horizontal surface, there is another lamina, liquid maintained on a stationary horizontal plate. The top layer of the liquid is moving with the constant velocity v. Top layer is concerned, we'll say it's moving to this direction with v. Here it is constant. This is another lamina not moving. It doesn't move. So therefore, this velocity is 0. So therefore, delta v is, upper one is, we'll say v1, this is v2, v2 is 0. Then v1 minus v2. That means v1 minus 0, that is v1. Then after that, cross-sectional area is given. Given means they mention about. Then F is equal to Newtonian equation, eta A delta V over delta X. So delta X value is given as D. Right? That is given as D. Then you can go ahead and get the answer for that. Then F is equal to eta A V1 delta V is delta V then V1 delta x is equal to d. It is given. D. This is the equation you have to obtain. Right, next one. They are asking you to show the velocity of the intermediate layers. So in between there are so much of layers. Their velocities you have to consider. That means here you get a certain velocity that is zero. Above that it is getting greater to the opposite direction. Like that. So like this, it is getting increase up to V1. So therefore, if you are drawing to that direction, you have to draw parallel lines. The first one must be larger, second one is shorter than that. So then third one is shorter than that. Like that, reduce the length. Finally, it should come to zero. This is the, but here it should be a one straight line like that. For a tube also, we did it early. Then third part. A person pushes a block of mass 0.5 on a horizontal floor. When a horizontal force of 0.2 applied on the block, it attains a constant velocity 0.01. If the thin layer of oil is applied on the floor, the horizontal force required to push the block with the same velocity reduces to 0.5. The contact surface area of the block is given 1 in 10 to the power minus 2 square meters. Calculate the coefficient of viscosity of the oil. Find the effective coefficient of sliding friction on the block and the flow after applying the oil layer. But here first one we have to consider. First part. A person pushes a block of mass 0.5 kilogram. Right? On a horizontal flow when a horizontal force of 0.25 Newton is given. So can you understand that part? I'll draw that part. Second situation, there is a block. A block block mass is given 0.5 kilogram. Then when a horizontal force of 0.25 Newton is applied on the block, it attains a constant velocity 0.01 ms minus 1. Anyhow, velocity is 0.01 ms minus 1. There should be a frictional force. That is F dash will see. So that means F equals ma if you apply for this direction, we got constant velocity, A is 0. Then F dash is or 0.25 minus f dash is equal to mass into 0. So that's 0. From that, if you want, you can find f dash. That is there. Now, second part is concerned. That is the first part. Second part, there is a layer of oil. There is a layer of an oil, and like this. Then moving with the same constant velocity. So then now what is happening is this layer is getting the same velocity as the block. Then we'll say this is F1 is a viscous force. And the force required to push this is now reduced to 0.05 newtons. Then again F equals ma horizontally towards this direction. Then you get 0.05 minus F1 is equal to mass into 0 because constant velocity 0. So F1 is 0.05 newtons. F1 is viscous force. Now again, just like the previous situation, apply this. F is equal to eta A delta V over delta X. I'm not going to do everything. Thickness is given delta V. This is you have to mention that the bottom layer is at constant. So they are on the flow. No? So therefore this delta V is V1 minus V2. V2 is 0. V1 is equal to same velocity 0.1 towards this direction. Why? There you mentioned that the layer in contact with the block, bottom of surface of the block is getting the same velocity. So therefore upper velocity is 0.1. This is not moving the bottom one, then see that is 0. The difference is 0.01, just like the previous one. Then we can find delta V. Delta X is given. Then cross area, contact area is given. Right? So force is given. Understood now? Then eta is unknown. This is also given. You can find it. Second one, find the effective coefficient of sliding friction when the block and the flow after applying the oil layer. So actually it is different now. Now new F is there. No? You use the new F value. Then F equals mu R and find mu. F1 is 0.6. F1 is equal to mu R. We consider the average mu for this. F1 needed one is 0.05, the second situation. Mu is unknown, R is known. So therefore substitute the value of R and get it. How to get R? You had to mark it here. This is R, downwards mg. mg is 5. 0.5 into 10 newtons. So then R minus 0.5 into 10 to 10 is equal to 0. F equals ma upwards. But it's not moving upwards, A is 0. Then after that, you can use F equals mu R, and this is how you are finding R, capital R. Then there is another part. What is the energy of that can be saved during 1 second due to the application of oil layer? They are asking about 1 second. One method is you can calculate for the first situation and second situation F. Two different F's are there. No? So the F into S is work done. W1, W2, first situation, second situation F1 into S. S1, S2 like that. But S1 is concerned within the same velocity they are moving. So S1, S2 are the same. That can be found how S is equal to ut plus half a t squared, a is 0. So then S is equal to u 0.1 into t is 1. That is C is 0.1. To substitute 0.1, 0.1, F's are known, get W1 and W2 and get the difference. Then one method. I'll teach you another method. Second method, work done, rate of work done, that's power. W over T. W is equal to Fs. P is equal to Fs over T. P is equal to F into S over T is velocity. Fv. That is power. Power is work done in 1 second or unit time. Then you can calculate separately using velocity is given. So therefore, you can calculate the values. Work done for the first situation, F1 into V. V is the same, 0.1. Second situation, second F into 0.1. Then get the difference. There are two methods. You can use one method. Remember, when you are again, I am giving certain instruction. For past paper questions are being answered. Normally, students are trying to go through the marking schemes and get the idea. I'm not going to say it's bad. It's okay. But basically, this is the method. If they ask the definition, write the definition properly. Normally you get nowadays 2 marks. But one part is missing, one special word is missing, then no, that is not the correct answer. Then definitions must be written according to the correct way. Needed, all the words should be there. Second one, then try to understand the question. After that, select the equation. So if you are going to select the equation, for that also you are given marks. After that, write whatever the physical quantities you have to write. A simple A radius. Then we'll say, for instance, 0.3 millimeters. Then convert into meters and write with the units there. All those. After that, write in the equation. That is called correct substitution. For that also you are getting marks. After that, you are getting for the correct answer with the units. Now remember, both must be there. Most of them chemistry papers, they separate like that. 5 marks for the numerical value, 5 marks for the units. just explained and said 5, 5. But 1 mark for that, another 1 mark for that. But here normally both must be there together. That is the actual marking scheme. Any explanations are there. Early, the first few questions I said no. When the block is kept like that, when it is moving with the particular constant velocity, the layer, liquid layer or oil layer which is in contact with the bottom surface or lower surface of the tube is getting the same way. Like that, those things quickly explain and state there. Then that is the marking scheme. If you write like that, maybe you may be writing one, sometime one may be more than the needed amount. That is not a matter. Rather than remembering everything one by one, that cannot be done. Right, next situation. Now we are coming to 2004 paper. In 2004, write down Poisson's equation for the flow of viscous liquid through a tube. Identifying the symbols. So you write Poisson's equation. Once we wrote it, Q is equal to pi a to the power 4 delta P or P1 minus P2 8 eta L. So describe all. Here you can write delta P if you want. Then pressure difference at the two ends of the tube. This is P1 initial first end of the tube pressure, second end of the Q is the rate of flow of liquid in volume. State of conditions under which Poisson's equation is correct. But delta P is written, you can say the pressure difference across the tube, not the delta P, pressure difference across the tube or along the tube. A is internal radius, L the length of the tube. State two of the conditions under which Poisson's equation is valid. I gave that earlier, that answer in the video 2, 4, part 4. There, when blood vessels are there, then I explained it, but anyhow I'll tell those conditions. But number 1, or just write, the liquid flow must be steady. Tube must be a straight one. Radius, internal radius must be smaller. Internal radius must be smaller. Actually, there is another one. Normally, it should be explained. The liquid must be incompressible. When the force is given, there is in the syringe, liquid was there, no? So it compressible, then it changes volume like that, no? So then you can't do that. But if you want, you can say the liquid must be homogeneous. That means the internal molecular forces are concerned the same in between same kind of particles. But better to write steady flow, underline steady flow and straight tube. You don't want to write everything. Remember those two and write, that is enough. Next one. Suppose that the radius of the cross section of the tube is R. The pressure difference across the tube is A and P. Of flow is Q. Write down an expression for the resultant force acting on the liquid if the tube due to this pressure difference delta P. They are asking the force. Force is normally here we get the pressure difference. No? Then force is equal to pressure divided by area. Then that is what we have to consider. So then the force needed is delta P into area. I'll explain if you want. Pressure here is P1. Then cross-sectional area everywhere the same. Then force is F1. Here pressure is P2. The force is F2 then. F2. Now they are asking what is the work done. No, they are asking the resultant force. The resultant force is now P1 is here, P2 is here. Actual situation, if you consider inside liquid, I am considering the mean hydrostatics. The pressure due to pressure, there is a force inside. There is a pressure due to that F2 from outside into the liquid. Then F2. Then resultant, this is flowing to this direction now. So therefore resultant force towards this direction. That means resultant force is equal to F1 minus F2. We have 2 is the opposite direction. F1 is equal divided by A is equal to P1. F2, then P2 is equal to F2 divided by A. F1 from this F1 is equal to P1A. F2 is equal to P2A. Then resultant force is equal to P1A minus P2A. That means P1 minus P2 into A is the resultant force. Note down. This is hydrostatic. This is not to be proved there. I consider liquid inside the pipe. Remember, here it is pushed towards that. When it is open, the pressure is coming outside towards inside. There is no need to prove, but I proved it in order to understand that it is under mechanics. Then resultant force. Substitute the values. Delta P into A. Pressure difference you substitute in Newton per square meter. A is equal to inside pi r, internal radius r, you write it there and describe, and pi r squared and substitute. Then you get the answer. Next one. The average speed of the liquid through the tube is given by V equals Q over pi r square. Show that this equation is dimensionally correct. show that this equation is dimensionally correct. Q is equal to, V is equal to Q over pi R square. Left hand side, V. Dimensions of left hand side, LT minus 1. Right hand side, Q over pi R square. Right hand side, dimensions. Dimensions of Q divided by pi is not needed. Dimensions of R square. So that means Q. Here Q is rate of flow. Right? So then how do you get it done? Rate of flow is L cube T minus 1. So this is LT minus 1 square. Then you are getting L cube T minus 1 divided by L square T minus 2. Now L square is taken up. Then you are getting L. Then T minus 1 is taken up plus 1. So then you get L square T minus 2, L cube wait, there's a small issue. So then wait, I'll check the cube. No, the equation pi r squared, no, sorry. This is pi r squared, right hand side, q over pi r squared, and you are getting r squared, not velocity. This is, sorry, this is r, no? That's right. This is L squared, sorry. Then you get directly, one is LT minus 1. So this is simple, R is L squared. Then you get LT. Then right dimensionally correct. Next one. You are writing, therefore, the equation both sides are, or right hand side is, dimensions of right hand side is equal to dimensions of left hand side. Therefore, it is dimensionally correct. That is how you are saying it. C part. Hence, show that the rate of work done by the pressure difference against the viscous force, and show that the rate of work done by the pressure difference against the viscous force is Q delta P. We'll see how to get it. Earlier I told that work done, prove that work done is equal to delta P. F1, F2 we marked and found it. Delta P into, then that is a resultant force, delta P. When you consider P1, P2 pressures, and here F1, F2, they asked us to find resultant force. We found. So then resultant force we consider. But here work done is resultant force into displacement. That is what you have to write. So when you consider displacement, we can say resultant force. How did you get resultant force? Towards this direction, F1 minus F2, we can say. F1 into displacement, we'll say S. This was F1 is equal to P1A, F2 is equal to P2A. That means P1A minus P2A into S. That means P1 minus P2 into AS. Like that you can get it. This is delta P. Delta PA S. Then this is R. No? Then A is equal to pi R squared. Delta P pi R squared S. S is now they are asking the not the work done, rate of work done. Rate of work done. Work done divided by time. Work done delta P pi R squared S divided by T. S divided by T is velocity. Then rate of work done is equal to delta P pi R squared V. But we proved that V equals Q over pi R squared. That was given to us and we proved that equation dimension. Right. So then delta P is here pi R squared. Then delta P pi R squared Q over pi R squared. Cancel out. Delta P Q. Q delta P is equal to delta P Q. Right, next one. They are asking our Poiseuille's equation is often used for approximate calculation of blood flow in human body. State two reasons why Poiseuille's equation is not strictly valid for blood flow through vessels in human body. I explained it in another one. So if you want, quickly note it down. Blood vessels are not straight. That was given early. Blood vessels are elastic. Cross-sectional area of the blood vessel is not uniform. Internal cross-sectional area, better to say. Internal cross-sectional area. Rate of flow of blood is not uniform. The last one, blood is not homogeneous. Homogeneous means between the particle, the forces must be the same. But here, composition, blood chemistry is concerned, different type of cells are there. So therefore, those forces are not equal. Therefore, it is not homogeneous. But even that we apply and get the equations. Right. So then next part. If the average rate of blood flow through a horizontally situated artery with uniform cross-sectional area having radius of 2 and length 220 is 2.5 cubic centimeters in per second. Calculate the pressure difference between the two ends. Average viscosity of the blood at the body temperature is, that is just coefficient. Normally they say sometimes viscosity. Now new way, when we say viscosity, that is coefficient of viscosity. Right. Here I'm not going to do everything, but I will just explain. Average rate of blood flow through a horizontal situated artery is uniform. Cross-section area is radius. R is equal to 2 millimeters. So converting to meters, like that. Then after that, length is L 20 cm, then 20 into 10 to the power minus 2 meters. After that, 2.5 Q. Rate is given as 2.5 in cubic centimeters per second. So 2.5, you have to get this into 10 to the power minus 6 cubic meters per second. After that, you use the equation Poiseuille. Remember, SI units, it should be converted to SI units and use it. Eta is given. If you can't understand what is that viscosity coefficient or just now normally we say viscosity means coefficient of viscosity. Remember that. The units you consider NSM minus 2 is there, that is eta. Suppose the radius of the cross section of the artery decreased to half of the original value due to the fat deposition. By how many times will the pressure difference across the artery have to be increased in the order to maintain the same rate of blood flow maintained in 3? So then same blood form, but they are saying decrease it half of the original value due to fat deposition. So then radius is given as 2 into 10 to the power minus 3. Now R is equal to 2 into 10 to the power minus 3 divided by 2. 1 into 10 to the power minus 3. So nu A, radius is this. According to that, use again pi A to the power 4. Then the delta B of P1 minus P2, delta B divided by 8 theta L. So calculate the new rate, but rate must be the same. No? So then new value for delta P or P1 minus P2 new value. You have to find that. Substitute and get it. A is known, eta, L all are the same, Q is the same. So then what happen is the end of the two ends of the this artery is concerned, what happen? Pressure increases. That is how the blood pressure increases. When the cholesterol is deposited there, it happens. Normally we consider cholesterol deposits there automatically. Not, we can say is deposited. If it is due to something can be said. Right. After that, third one, B. No, the second one. By how many times will the rate of work done by the heart against viscous force have to be increased to maintain the same rate of light? How many times will the rate of work done? So work done by the heart, that day I gave it. Work done is equal to which one? W equals, once I Q delta V. So then we can consider that one W is equal to Q delta V. That day I proved it. The pressure difference is known. For the first pressure difference, Q is known. W1 you can find. W2 for the second situation. Pressure differences are different. So then W2, get the W2 is greater. Then what happen is get the difference. The difference is the needed, additionally needed one. After that, they are asking, sometimes the doctors prescribe drugs that reduce blood viscosity to patients having high blood pressure. Briefly explain how such drug bring relief to the patients. Assuming that you have to say like, no. Yeah, I'll give that answer. Then first one, according to the Poiseuille's equation, you write the Poiseuille's equation first. Then P1 minus P2 is equal to Q8 eta L over pi a to the power 4. Get this equation. Now we can say P1 minus P2 or delta P directly, Q is a constant, A all are constant, directly proportional to eta. Since all are constant. That means we want to reduce delta P. Delta P reduces if eta reduces. Then write coefficient of viscosity or viscosity reduces by the drug, then pressure difference decreases. Then we'll go to 2008 question. Poisson's equation can be written as Q equals pi delta P R to the power 4 theta L. In this case, A or R is taken to the back. First, they consider the P1 minus P2. After that, you know how to identify each physical quantity. I'm not going to say it. So the above equation is dimensionally correct. You know how to do that. Left hand side, right hand side, separately right hand. Substitute the values and finally show left hand side and right hand side dimensions are equal. Therefore, the equation is dimensionally correct. Crude oil of viscosity 0.9 kilogram M minus S1 and density has to be delivered from a harbor to a refinery using a straight horizontal metal tube of internal radius 20 and length 1 kilometer at average speed of 1 ms minus 1. Calculate the pressure difference. That should be, now they have given the speed. That is a problem. According to the speed it is given. Internal radius is given as 20. Average speed is given as 1 millimeters per second. Now see, Q is not given here in this question. Speed is given. Speed is V. We'll see what we can do it. Cross-sectional area is A. Consider unit time. Unit time. And the length of crude oil in unit time is equal to, we'll say, capital L. So unit time it travels or moves for L. Then volume of oil in unit time is equal to A into L. Why? Distance it travels is this much. Then volume is equal to pi r squared into L. For unit time is concerned, velocity is equal to length s divided by t. So then V is equal to S is L, time is 1, T is equal to 1. Then L is equal to V. Therefore, volume is equal to pi r squared V. V is the velocity. For unit time. That means rate. Unit time. Rate is pi r squared v. Then you can find v. Sorry, q. After that you use, then q is equal to pi a to the power 4 delta p or p1 minus p2 over 8 eta L. So these two must be equal. Pi r squared v is equal to pi a to the power 4 p1 minus p2 divided by 8 eta L. Pi cancel off. Here they are asking p1 minus p2 value is equal to 8 eta L r squared v over a to the power 4. Substitute the values. First you write a is in units with the units in SI units. All after that substitute. What is the minimum power needed to deliver the oil through the pipe at given rate? This equation I proved early. Can you remember? I consider hydrostatics and proved it. So then work done is equal to force. Check the previous past paper. We got P1 minus P2 into A as the force into the distance as S. After that, same situation. Rate is concerned, rate of work done. Work done divided by time. So then P1 minus P2 into A S divided by time. Then S over T is V. P1 minus P2 AV. I proved it early. But here also you have to prove and show. Mechanics is there. Then substitute the values. Then you get the answer. At what radial distance at the speed of oil in the tube, its maximum and minimum values. They are asking maximum and minimum values. Read the question. What is the minimum power needed to deliver oil? To calculate the pressure difference and should be maintained across the tube. Then minimum power needed to deliver through the pipe. Power means work done. At what radial distance at the speed of oil in the tube, it has maximum and minimum values. Read it properly. When we consider the theory, once I told in a pipe, the one which is flowing the straight line along the axis is having the maximum speed. We draw the diagram also. That day we drew it. Normally, here, this is the tube. The axis one is having the maximum V max. So that means R is equal to 0. This is the tube inner wall. Inner wall is having velocity of 0. Then your answer must be maximum velocity along the axis of radius when radius is 0. Then the least value is 0. Least velocity is 0 for the layer in contact with the inner wall of the tube. Therefore, R is 20. R is given as 20. The internal radius of the metal tube is decreased by 10% due to deposits. What percentage of the pressure difference across the tube should be increased in order to deliver oil at the same rate mentioned above? 10 divided by 9, I think, coming to the answer. Therefore, they have given you 10 divided by 9 is equal to 1.11. I'll guide you to do that. Internal radius of the metal tube is decreased by 10%. The first you write Q is equal to pi A1 to the power 4 delta P1. Delta P1. P1 minus P2, I consider delta P1. Or 8 eta L. Second situation, Q is equal to pi A2 to the power 4 delta P2 divided by 8 eta L. Length eta all are. They are saying the rate must be the same. Understood? Calculate the pressure difference that should be maintained across the tube. The internal radius of the metal tube is decreased by 10%. That means A2 is equal to 90 divided by 100 of A1. 10% reduced means 90% remaining. Then this is equal to A2 is equal to 9 divided by 10 A1. So then you can substitute it here. You can equate these two because Q is the same rate. After that, substitute A2 in terms of A1 and divide. No, not divide, equate this. If you want, I'll do. Pi A1 4 delta P1 divided by 8 eta L is equal to pi A2 to the power 4 delta P2 over 8 eta L. See, these are cancelling off. Then delta P2 divided by delta P1 is equal to A1 over to the power 4, A2 to the power 4. So that means A1 over A2 to the power 4. Then A1 over A2 is equal to, you get A1 over A2 delta P2, right. Then from here you get the ratio. A1 over A2 ratio can be 10 over by 9. So substitute it here and get the answer. If they are, since they are asking the percentage, how much it should be increased? Difference divided by initial delta P, that is delta P1 into, or in other words, delta P2 minus then into 100. That is the percentage. Can be done. Answer is 52%. Roughly around that value. Two smaller tubes having the similar radii and lens are now fitted to the end of the metal tube mentioned in B above, and oil is delivered to two other refineries instead of the refinery mentioned in B. The length of the smaller tube is 1 kilometer and the pressure difference across the tubes are equal. Find the radius of the smaller tube. Now I'll explain it. This one also I explained this type of situations early in part 4. Then one large one, then converting to two pipes like this. Two smaller ones. Two refineries there. Refinery 1, refinery 2. Lengths are equal. So then L. Rate here is Q. Here rate is Q1. Here rate is Q2. Then the radii are different. Different values are there. This is R. This is R1. This is R2 we'll consider. Then Q is equal to pi R to the 4. Then pressure difference. So normally this is the way. Q is equal to Q1 plus Q2. Then Q, capital Q, you have to consider. Then they are saying delta P values are the same. the same, the pressure difference across the tubes are equal. But anyhow, we'll write this delta P divided by A theta A. This is also L. Then Q1 pi R to the power 4, sorry, R1 to the power 4, delta P same. Then 8 eta L, L is the same, eta same. Q2 pi R2 to the power 4 delta P over 8 eta L. Then Q is equal to Q1 plus Q2. Then Q is equal to pi R to the power 4 delta P A theta L is equal to pi R1 to the power 4 delta P divided by A theta L plus pi R to the power 4 delta P divided by A theta L. So they say eta L delta P all are the same. So then cancel off. Delta P same. Then pi same. Cancel off. Then finally you are getting R to the power 4 is equal to R1 to the power 4 plus R2 to the power 4. In this tube, they say the two similar length and pressure difference are there. The length of our smaller tube is 1 kilometer and the pressure of difference across the tubes are equal. They are saying similar radii. That means R1 is equal to R2. Then R to the power 4 is equal to R1 to the power 4 plus again R1 to the power 4. Both are equal. Then 2R1 to the power 4 is R to the power 4. Then after that, you have to find R is equal to R to the power 4 divided by 2. Then substitute the values and take the 1. R1 is R to the power 4 divided by 2, 1/4 power. You have to use log to solve this. Right. Now I have completed all the questions from 1990 up to one question I skipped because it was having too much of mechanics. But anyhow, I just tell you about that. That was related with the inclined surface. So when the object is there in G, friction is there, what's happening you can consider. And you can use F equals MA and find what is it. After that, oil is spreaded there. Then viscous force you find using Q. F is equal to eta A delta V over delta X. And substitute that value and get the last part. Okay. So then I feel that the explanation is really needed to the students. Normally what happens is model answer questions are there, we'll see. Then they are normally they do not explain that. You have to think and get it. Correct application can be understood in this way, how to use it. Now you can try out the other question from 2010 onwards until the last few years. Normally, to practice for the exam, the best method is you should keep certain year papers without doing section by section. But normally it cannot be done in that way because most of the time you are trying to do all the questions under each section. But if you can keep 5 years papers without doing in the last month or last 3 weeks, if you start to do that, then the assessment is concerned, that is your result. Basically, when you are doing section by section all the question and get the past papers of the last 2-3 years and try to do quickly, you can do. That is not the real assessment. Okay,